Okay, let's just jump right into this. Because if your calendar is anything like mine, yesterday was supposed to be a nice, quiet Monday.
Right.
Today is Tuesday, January 27th, 2026. And usually when we talk Microsoft security, we're talking Patch Tuesday. It's a rhythm.
It's the heartbeat of the IT world. Boring is good.
Boring is good. Boring is safe. Exactly. But yesterday was Monday, January 26th. And Microsoft did something they really hate doing. They broke the rhythm. They dropped an out-of-band security patch.
Which is just the polite corporate way of saying, we have a fire and we cannot wait 2 weeks to put it out.
Right. When the biggest software company on Earth breaks its own schedule, you know the building is smoking. So that's why we're here. We're going to figure out why the alarm is ringing. We're diving deep into a high-severity, zero-day vulnerability in Microsoft Office. The headlines are, they're already screaming active exploitation, an emergency patch.
And that gets the adrenaline pumping in security centers, for sure.
Right.
But honestly, panic is the worst possible reaction in cybersecurity. It just leads to mistakes.
That is exactly why we're doing this. Our mission for this deep dive is to cut through that panic. We've pulled the raw data, the advisory from Microsoft, the technical breakdown, the emergency directives from the U.S. government. We're going to figure out exactly what this thing is. It has a name, by the way. CVE-2026-21509.
Rolls right off the tongue.
We're going to break down how it actually attacks your system, the mechanics of the burglary, and then, most importantly, we are going to walk through the specific and honestly kind of complex steps you need to take to fix it.
It's true.
Because depending on which version of Office you are running, this isn't just a click OK situation. It might involve a bit of digital surgery.
Yeah, for a lot of users, this is going to be totally invisible. But for the people managing older systems or, specific business environments, this is a bit of a maze. But if we start with the facts, the maze gets a lot easier to navigate.
Okay, let's start with the stats.
Yeah.
We have this tracking code, CVE-2026-21509. The sources say it has a severity score, a CVSS score of 7.8 out of 10. Now, I see 7.8 and I think high, but I don't think the internet is melting. If this were a nuclear disaster, wouldn't it be a 10?
That's a really important distinction to make right off the bat. A 10.0 usually implies something like remote code execution with zero interaction.
Okay.
That means the bad guys can get into your system just by sending a packet of data to your IP address. You don't have to touch anything, click anything. You don't even have to be at your desk. That's a 10.
Okay, that's the wormable stuff that keeps experts like you up at night.
Exactly. Now, a 7.8 is still high severity, but the math behind that score tells us there's a condition attached that requires user interaction. The attacker can't just break in. They have to trick someone on the inside to unlock the door.
So I have to make a mistake for this to work.
You or someone in your organization has to be the weak link, yes.
Okay, before we get to the mistake I'm inevitably going to make, let's talk about the lock itself. What is actually broken here? Microsoft calls it a security feature bypass. That feels a little vague.
It is vague, so let's get technical for a second. To understand this bug, you have to understand a piece of technology that is, well, ancient in computer years. OLE.
OLE, object linking and embedding.
Correct. It's the technology that lets different Windows apps talk to each other and share content. It's the magic that lets you take a live Excel chart and embed it inside a Word document.
I use it all the time.
We all do. But because it's so complex and it involves different programs handing off data, it has historically been a very popular playground for hackers. It's a large attack surface, as we say.
So Microsoft has to know this, obviously.
Oh, absolutely. Over the years, they have built very specific defenses, what they call OLE mitigations. Think of it like a security checkpoint, specifically designed to scan data that's trying to cross from one app to another. It checks if the data is safe.
And CVE 2026-21509.
It's a fake ID. The official technical description is reliant on untrusted inputs in a security decision.
Translate that for me.
Essentially, the security guard, the code that's supposed to check if the input is safe, is asking the input itself, hey, are you safe? And the malicious input says, yeah, I'm totally cool, trust me.
Wow.
And because of a logic flaw in the code, the security guard believes it.
So the system is relying on the bad guy to tell the truth.
In a nutshell, yes. The vulnerability bypasses those OLE mitigations that are supposed to protect you from vulnerable COM controls.
COM controls. Component object model.
We are really digging into the bedrock of Windows here.
We are. And that's what makes this so fascinating. This isn't a bug in some flashy new AI feature. This is an exploit targeting the legacy architecture that underpins the entire operating system. It's like finding a structural crack in the foundation of a skyscraper.
So the foundation has a crack, and the security guard is asleep. That brings us to the how. We established this isn't magic, it requires me to do something.
It requires social engineering. For this exploit to work, the attacker has to create a specially crafted office file. That's the weapon. But a weapon on a server doesn't hurt anyone. They have to deliver it.
So we're talking email.
Email is the most common vector, yes. A phishing campaign. Please check this urgent invoice, updated layoff notice.
The classics.
The classics work for a reason. The vulnerability exists in the code that processes the file when it loads. So the moment you double-click that file and Word or Excel tries to render it, the exploit triggers.
And boom.
Boom. It bypasses the OLE mitigation we just talked about, and it executes whatever malicious code the attacker hid inside.
Okay, here is where I need you to settle a debate I have with myself constantly. I am the person who lives and dies by the preview pane. You know, an Outlook or File Explorer where you single-click the file and it shows you a snapshot.
It's a great productivity feature.
But does it trigger the exploit? Technically, the computer is showing me the file. Is that enough to get me infected?
This is a fantastic question, and it's one of the first things I looked for in the source material. And I have very good news.
Oh, thank goodness.
The sources are explicit. The preview pane is not an attack vector.
Why not? Doesn't it have to read the file to show it to me?
It does, but the preview pane uses a lightweight renderer. It's a stripped-down version of the engine. It doesn't load the full application stack, and crucially, it doesn't load all those heavy, complex OLE and COM capabilities. So the specific lock that this exploit breaks, the preview pane doesn't even use that door.
That is a massive relief. So if I see a sketchy email, highlighting it to preview it is safe. Double-clicking it to open it is the danger zone.
Precisely. The preview pane is your safe harbor in this storm.
Okay, so we know the mechanism fake ID at the OLE checkpoint. We know the vector email attachments. Let's talk about the who. Who found this thing?
This was an internal bust. The discovery is credited to MSTIC, the Microsoft Threat Intelligence Center, along with the Microsoft Security Response Center and the Office Product Group security team.
So the good guys found it.
They found it, yes. But the context of how they found it is the reason we're recording this deep dive today. They didn't find this during a routine code audit in a lab. The report confirms active exploitation.
That phrase always sends a chill down my spine.
It should. It means this isn't theoretical. Microsoft found this bug because they saw someone using it to break into systems in the real world.
Do we know who? Is it a ransomware gang? A nation state?
That is the big unknown. The sources are incredibly tight-lipped here. Microsoft has not shared details about the scope of the attacks or the identity of the threat actors. We just don't know.
But even if Microsoft isn't saying, the U.S. government's reaction speaks volumes, doesn't it?
It shouts. This is where we have to look at CISA, the Cybersecurity and Infrastructure Security Agency. As soon as this news dropped, CISA added CVE-2026-21509 to their KV catalog.
The KV catalog. Known exploited vulnerabilities.
It's the most wanted list for software bugs, but it's not just a list, it carries legal weight. Being on that list triggers a federal mandate. Federal civilian executive branch agencies have been given a strict deadline. They must apply these patches by February 16, 2026.
Today is the 27th of January. That gives them barely 3 weeks.
In the world of government bureaucracy, 3 weeks is light speed. It's basically do it yesterday. That tells you that CISA views this as a critical risk to federal infrastructure.
And the logic for our listener is simple. If the U.S. government is scrambling to fix this in 3 weeks, you probably shouldn't wait 3 months to update your laptop.
Exactly. The I'll get to it later strategy is officially expired for this one.
So let's pivot to the fix. Because looking at the advisory, this isn't a one-size-fits-all situation. It seems like we have two very different scenarios.
We do. It's a tale of two cities. We have the modern cloud users and the legacy on-premise users.
Let's start with the modern crowd. Scenario A. This is anyone on Microsoft 365 or Office 2021.
Which is likely the majority of our listeners. For these users, the fix is actually being applied via a service-side change.
What does that mean, service-side?
It means Microsoft is changing the configuration in the cloud. Since your Office apps are constantly talking to their servers, they can just push a command that says, hey, stop using that vulnerable code path. They can essentially flip a switch remotely.
So I don't need to download a massive file.
No. But, and there's always a catch, the source notes that for this protection to actually kick in, users will be required to restart their Office applications.
The classic IT wisdom. Have you turned it off and on again?
It sounds silly, but it's critical. If you are the type of person who leaves Outlook open for 3 weeks straight, you are vulnerable. The new configuration can't load while the old one is running.
So step one for almost everyone, stop what you're doing, save your work, and fully quit every Office app. Then open them back up.
That's the easy path. Now, scenario B, the users on Office 2016 and Office 2019.
The perpetual license folks.
Right. These versions don't get those slick server-side updates. If you're on these versions, and many businesses still are, you have to install a specific security update. It's a manual patch.
I have the version numbers here. So if you're an IT admin or just a meticulous user still rocking Office 2019, you need to check these.
And pay attention to 32-bit versus 64-bit, although thankfully for this patch, the build numbers are the same.
Okay, here we go. For Microsoft Office 2019, you need to be on version 16.10417.20095.
That's 10417.20095.
Correct. And if you're keeping it old school with Microsoft Office 2016, you're looking for version 16.0.5539.1001.
And if your version number is lower than that, you have a hole in your shield. You need to run Windows Update immediately.
Now here's where it gets really interesting and honestly a little scary. What if you can't patch? The sources mention a mitigation, a workaround.
Yes. And I have to say, looking at the instructions for this,
Yeah.
this is not for the faint of heart. This involves editing the Windows registry.
The registry, the dark, scary basement of Windows where one wrong click turns your computer into a paperweight.
I wouldn't go quite that far, but yes, it requires precision. The source explicitly advises taking a full backup of the registry before you even try this.
Okay, that tells you something. So let's just walk through this so people understand the complexity. Step one.
Step 1 is the same as before. Exit all Microsoft Office applications. Do not skip this.
Step two. Start the registry editor. So you hit the Windows key, type regedit, hit enter.
Correct. Now, step 3 is where it turns into a detective game. You have to locate a specific subkey, and the path changes depending on your system.
I'm looking at these paths in the source. It's like a choose-your-own-adventure book.
It is. For standard 64-bit Office, you go to HKey Local Machine Software, Microsoft Office 16.0 Common COM compatibility.
But if you are running 32-bit Office on 64-bit Windows, which is super common.
Then you have to find the WOW6432 node.
A what node?
WOW6432 node stands for Windows on Windows 64-bit. It's a compatibility layer. You have to go to HKey Local Machine Software, WOW6432 node, and then find the paths from there.
Okay, so let's say we navigated the maze. We found the COM compatibility folder. Now we have to add a new key.
Yes, and we can't just name it fix the bug. We have to identify the specific component we want to disable, and we do that using its class ID. You have to right-click COM compatibility, choose add key, and name it with the specific GUI.
I'm going to read this out just to illustrate how precise this is. You have to name the key. EAB22AC3 30C1 11CF A7EB 000C05BA0B.
Including the curly brackets.
What is that string? It looks like an alien serial number.
That is a globally unique identifier. Every single component in Windows has a unique name like that. That specific string identifies the exact 25-year-old piece of code that contains this vulnerability.
So by creating a folder with that name, we are pointing a finger at that one tiny piece of the system.
Exactly. We are singling it out.
Okay, we made the key. What goes inside it?
Inside that new key, you create a DWORD 32-bit value.
And we name that value compatibility flag.
Right. And finally, the payload. We set the hexadecimal value to 400.
400. What does 400 say to the computer?
In the language of COM, that flag essentially means kill bit or do not load. We're telling Office, if any document tries to wake up the component named EAB22AC3, block it immediately.
It's a surgical strike. We aren't turning off all of OLE. We're just manually locking the door on this one specific vulnerable microcomponent.
And that's why this mitigation works. But again, if you mistype one character of that GID or type 4000 instead of 400, it does nothing.
So copy-paste is your best friend here.
Absolutely.
Let's just zoom out for a second. We've covered the, a 7.8 severity bypass, the how crafted files via email, and the fix, restart, patch, or registry hacking.
Uncovers the tactical side.
But strategically, does this worry you? Is this just business as usual?
It is business as usual, but the tempo is what matters. The fact that SUSE is issuing 3-week deadlines, the fact that attackers are digging up 25-year-old OLE components, It just shows that the attack surface is massive.
It feels like we are constantly patching holes in a ship that was built in the 90s.
We are. Legacy code is the gift that keeps on giving for hackers. You can secure the cloud, you can secure AI, but if there's a dusty old COM object from 1999 deep in the kernel, they will find it.
So let's distill this into action items. What does the listener need to do right now?
3 things. First, identification. Know what version of Office you have. Are you 365? Are you 2016? Remediation. If you are 365, restart your apps right now. If you're 2016 or 2019, go to File Account Update Options and hit Update Now.
And third,
Behavioral. Trust nothing. Active exploitation means the campaigns are running now. If you get an invoice you didn't ask for, don't open it. If your boss sends you a weird file, call your boss.
and use the preview pane.
Use the preview pane. It's the unsung hero of this entire deep dive.
Before we wrap up, I want to leave you with a thought. We've spent all this time talking about registry keys, version numbers, OLE objects. But looking at all the source material, there is a silence that is really loud.
The silence about the attackers.
Exactly. We have Microsoft issuing an emergency patch on a Monday. We have the U.S. government setting a frantic deadline. We know it's being used in attacks right now, but we have zero information on who is doing it or who the victims are.
It really highlights the nature of the silent war happening on our networks. The battles are fought in the dark. The only evidence we regular people ever see is a cryptic update notification or a registry key like EAB coming to AC3. It makes you wonder, how many other battles are happening right now inside our systems that we don't even have a patch for yet?
Something to think about while you're restarting your Word documents. Stay safe out there, check your updates, and we'll see you on the next deep dive.
Stay secure.